Welcome back everybody. This is our 10th class in JEE mains previous year questions for chapter current electricity. Before this video we have made 9 videos in this series and all of those videos are available on our channel's playlist section. Name of channel is again Point Basics and you can find all related videos in the playlist, dedicated playlist for JEE mains previous years. We have also started similar series for NEET previous year, so you can again go to channel and in playlist section can find those videos. And if you find these videos useful, helpful, then do press the like button, share them and subscribe to our channel. It helps a lot when you share and subscribe. Also, if you want to support us financially, then you can scan any of QR codes in front of your screen and donate us with whatever amount you want. With your donations, we will be able to keep on making these videos on regular basis. Now with this, let's start today's video, and we will be starting from question number 85. I think this was the last question which we solved in the previous video, and let's start with the next question. So let me adjust pen thickness slightly, and here it is. So a 2-watt carbon resistor is color coded with green, black, red and brown respectively. The maximum current which can pass through the resistor is. So we have given the color code. First, using the color code, we will find out the value of resistance, and then using the value of resistance, we can find out the power of the resistance. So the colors are green, black, red and brown. So these are the colors which given to us. Now for coding, while color coding, green comes at 5, blacks comes at 0, blacks give us 0 and red give us 2. So our resistance is 50 into 10 raised to power 2 ohm plus minus brown color give us 20% tolerance. So plus minus 20%. So this is the value of resistance. Now we have to find the maximum value of resistance. So assuming this to be mean value, we know that power is given by I square into R. So 2 is equal to I square into value of this. So 50 into 10 raised to power 2. And from this, I will be under root 2 divided by 50 into 10 raised to power 2. Now what we can do here, we can multiply it by 100 and into 10 raised to power minus 2. We can just simply write 2 is equal to 200 into 10 raised to power minus 2. It makes calculation slightly easier. We will get here 4. So under root of 4 is 2, and this 10 raised to power 2 plus 2 will go on the top and will become minus 4, and under root of minus 4 will be 10 raised to power minus 2. So current will be 0.02 ampere, or we can say, we can write it like 20 into 10 raised to power minus 3 or 20 milliampere. So option A matches here. And you can also have a doubt that as this resistance has 20% tolerance, we can say 20% value can vary. So to find a maximum value, because we have to find the maximum current, R should be minimum. So if we take this 20% on the lower side value for this resistance, let me explain that. As we know that given resistance is 50 plus 50 into 10 raised to power 2 plus minus 20% tolerance. So let's calculate 20% of this into 20 by 10 raised to power 100, and we will get 1000. So plus minus 5000 ohms. Now this is 5000 ohms, so we can write effectively R is equal to 5000 ohm plus minus 1000 ohm. Now minimum value of this resistance R minimum will be around 4000 ohm and maximum value will be 6000 ohm. Now as we have to find the maximum current and power is fixed, so current to be maximum, resistance has to be minimum, and minimum value of resistance is 4000 ohm. So 2 is equal to I square into minimum value of R, that is 4000. And now using this we can say I square is equal to 1 by 2000 and it will be approximately equal to under root, that is the value of I. Now how we can solve it? We can write it like this: 1 by 2 into 10 raised to power minus 3. We can write it further like this: 5 into 10 raised to power minus 4, and root of 5 is around 2.2, and 10 raised to power minus 4 is root of 10 raised to power minus 4 is 10 raised to power minus 2, and we can write it 22 milliampere. So actually maximum current, assuming that tolerance is true, 20% tolerance is there, or 20% error we can say is there, then maximum current can be up to 22 milliampere. And if we match all the options, we don't have 22 milliampere as option, we have only 20 milliampere as option. So we will be checking here 20 milliampere as a right answer. Let's move to next question. Current of 2 milliampere was passed through an unknown resistance which dissipated power of 4.4 watt. So power is given 4.4 watt and current is 2 milliampere. Dissipated power when ideal power supply 11 volt is connected across it. Now as it is given power is ideal power supply, so power supply does not have its own resistance. Now as we know, value of resistance passing through, or value of current passing through this unknown resistance, first we will calculate value of this unknown resistance, and that can be calculated as that power is equal to I square into R, and from this R is equal to P by I square. So power is 4.4, I square will be 2 into 10 raised to power minus 3 into 2 into 10 raised to power minus 3. So this will give us 2.2 and this will further give us 1.1, and we will be left with 1.1 into 10 raised to power 6 ohms. So this is the value of resistance, and value of resistance stay constant. So when power supply of 11 volt is applied, so our new power or new dissipated power will be V square by R, as potential is constant here and resistance is also constant. So it will be 11 times 11 divided by value of resistance. We can write it 11 into 10 raised to power 5, adjusting the decimal here. So it will be 11 into 10 raised to power minus 5 watts. So option A will be the right answer. Moving to next question. Constant volt is applied between the two ends of a metallic wire. If the length is halved and the radius of the wire is doubled, the rate of feed developed in the wire. So let's slide question slightly. Now we will solve this question in two parts. First, original wire. In case of original wire, our resistance is R node, length of wire is L node, and we can say radius of wire is R node. So we have formula for resistance, that R node is equal to resistivity of the wire, length of the wire divided by its area, that will be pi R node square. Now we can say modified wire. Modified wire. In case of modified wire, length is held, so L becomes L naught by 2. Resistance is double, radius is double, sorry. So radius becomes R naught into 2. So again, as these parameters are changed, so our new resistance, we can say R, will be equal to rho will stay as it is because its resistivity, and resistivity of a wire does not change when some of its parameters is changed. And this is why, because material of the wire is same, so resistivity of the wire depends upon its material, and if material is not changed, resistivity will not change. Now resistance will be rho times new length, that is L naught by 2, into new area, that will be pi, times square of 2r, that will be 4r naught square. So we can write it is rho L naught divided by pi r naught square into 1 by 2 into 4, so 1 by 8. And this is the resistance of original wire, so that will be r naught by 8. Now rate of heat developed in the wire, so ratio of rate of heat developed, that we have to calculate. And we know that rate of heat or heat by time is known as power, and power is equal to, we have two formulas for wire, that is for power V square by R and also I square into R. Now as in this case voltage is constant, so we will use formula which includes potential. So P node, power consumption for the original wire, will be V square by R node, and P, power consumption for the modified wire, will be V square by R naught divided by 8. So if we find the ratio P node by P, it will become V square by R node into V square by R node divided by 8. So 8 will go here, and here it is, V square get cancelled. So P node by P is equal to 1 by 8, or we can say P is equal to 8 times of P node. So power consumption is increased 8 volts. So option A will be the right answer. Moving to next question. Here we have figure shows 3 circuit 1, 2, 3 which are connected to a 3-volt battery. If the power dissipated by configuration 1, 2, 3 are P1, P2, P3 respectively. So we have to find out we can say relationship between the powers, and as we see potential is equal here in all of the cases. Potential here is, in the first case is 3 volt, second case 3 volt, third case 3 volt. So potential is equal for all three. What does it mean? As we know that when potential is equal, then the formula for power is V square by R. As potential V is equal for all of these, so just we have to calculate the value of resistance for each of these. And if we are able to find the value of resistance, then when we can easily compare their powers. So let's do for the first case, and for that let me take a screenshot of it so that I can easily make you understand. For the first, and paste it here, rotate it and increase in size. So you can see the basic figure here. Now suppose Let's mark the points. This is point A, point B, point C, and point D. And here we will write down the final resistance R1 for the first circuit. Now between point A and B there is 1 ohm resistance. So let's say this is point A, this is point B. From between A and B we have 1 ohm resistance. Now between A and D, sorry, not A and D, between B and D, between B and D we have again 1 ohm resistance. So between B and D we again 1 ohm resistance. Now there is another point, C point. Between A and C, from A to C there is 1 ohm resistance. So from A to C there is 1 ohm resistance, and from B to D, from B to D there is 1 ohm resistance. So that we already solved. Okay, the next one is C to D. C to D there is 1 ohm resistance. So C to D there is 1 ohm resistance, and C and B are connected by a 1 ohm resistance. So C and B are connected by 1 ohm resistance. So here totally we have 1, 2, 3, 4, 5 resistance, and here we again have 1, 2, 3, 4, 5 resistance. So our resistance, number of resistances are matched, and our connections are also matched. A to C, then C to D, A to C, then C to D, and then we can say B to D, B to D, and C to B, C to B. We have all this, and you can see easily, now you can recognize it easily, it is a Vein bridge. And as value of all resistances are equal, so it is a balanced Vein bridge. So in case of a balanced Vein bridge, this middle resistance is ignored, and we have now 1 plus 1 2, 1 plus 1 2, 2 ohm and 2 ohm in parallel, and effectively they will give us 1 ohm resistance. Now if we can see in the figure 2, here again this is a balanced Vein bridge, and again this middle resistance will be ignored, and R2 will again give us 1 ohm as a total. Now coming to, okay, I made a mistake here, slight mistake. In case of second option, first one is right. Second is not our Vein bridge. Actually, it would have been Vein bridge if circuit should be if circuit would have been like this. Let me show. If our circuit would have looked like this, then it will be a Vein bridge. But in case of this, here we have connection between these two arms at where battery is connected, so it is not a Vein bridge circuit. It's actually 2 ohm, 2 ohm and 1 ohm in parallel. So this circuit is something like this. 2 ohm, these 1 ohm and 1 ohm are in series, so their combination is 2 ohm. Then we have 1 ohm, and then we have 2 ohm. All of these are in parallel, and their combined value will be 2 and 2 in combine give 1, and again 1 and 1 in combine will give us half. So this is our final resistance of R2 is half ohm. Now coming to third circuit, as this part we have already solved, this will give us 1 by 2 ohm or 0.5 ohm, and that in series with 1 ohm will give us 1.5 ohm. So R3 is equal to 1.5 ohm. So we have a resistance of all of these three, and we can see from this formula that power is inversely proportional to value of resistance. So higher the value of resistance, lower will be the power. So R3 will be the lowest, R1 will be the intermediate and R2 will be the highest. So we can say P2 will give us highest power, then followed by P1 and then followed by P3. So here it is, option C will be the right answer. Moving to next question. The resistance of an electrical toaster has a temperature dependence given by this formula. In its range, operating range is at T node 300 Kelvin, R value is 100 ohm, and at T 500 Kelvin, value of R is 120 ohm. The toaster is connected to a source at 200 volt. Temperature raised from 300 to 500 in 30 seconds. Total work done in raising the temperature will be. So to solve this question, first we have to write down first what we will do. First we will write this formula and find the value of variables involved in this formula so that we can use them further. So let's write that RT, let me make it slightly thinner, is equal to R naught into 1 plus T minus T naught. Now in the third line, we know that at T is node, T node is equal to 300. When T node is 300, R is 100 ohms. So here R is 100. So we can say, right, at T node is equal to 300 Kelvin. R is 100. So this R is 100 equal to R node 1 plus T minus T node. Now value of T node is 300, we know, and value of T is not provided here. As you can see that after 100 ohm there is mentioned that and at T is equal to 500 Kelvin. So when it is mentioned that at T node is equal to 300 Kelvin, it means that our measurement temperature with respect to which we are calculating our alpha, that is T node, that is 300 Kelvin, is also equal to T at this particular observation. So here we are taking observation at its base temperature upon which temperature all the calculation are being done. So at T node is equal to 300 Kelvin, when resistance is 100 ohm, the normal temperature or T is also 300 Kelvin. So in this case, T and T node are equal, and we forgot alpha here. So T and T node are equal, so it will be alpha times 0, and from this we can write R node is equal to 100 ohms. Now at T is equal to 500 Kelvin, resistance is 120, so R is 120, R node is just we solved, that is 100 equal to 1 plus alpha times 500 minus T node, that is 300 mentioned in the question. 500 minus 300, that will be 200, and this will be 12 by 10 is equal to 1 plus 200 times alpha. Further solving it will give us 2 by 10 is equal to 200 alpha, and alpha will be 10 raised to power minus 3. So now coming to the second part, the toaster is connected to voltage source at 200 volts, so potential is 200 volt, and temperature is raised at constant rate from 300 to 500 Kelvin. So temperature is raised from 300 Kelvin to 500 Kelvin at constant rate. So if it is increasing at constant rate, we can say temperature increase is linear, then we can find we can form a relation between these two temperatures with given time is 300 Celsius. So we can say temperature or theta, temperature theta at any time will be 300 plus 500 minus 300, that is the actual increase in temperature, divided by time, that is this increase happened in 30 seconds, into t, time t. So actually we will write it like T, because here capital T is represented by temperature and smaller t is represented by time. So this we can write as T is equal to 300 minus 200 by 30, that will be 20 by 3, into time, and this time will vary from 0 to 30 seconds, and we can further write it like this: T minus 300 is equal to, sorry, here we have plus 20 by 3 into t, and we know value of 300 is equal to t naught. We know that 300 is equal to t naught, so this is actually value of t minus t naught. So t minus t naught is equal to 20 by 3t. Now coming to the last part, total work done in raising the temperature. So we have to find out total work done, and we know that work done, it will be work done we can write, as we know that power is just rate of doing work. So work done will be power into time, or we can say small work is equal to P dt, and power will be potential by resistance, V square by R. So dW will be V square by R into dt. Now value of this resistance we know by the formula which is already given to us. It is, here it is, R node into 1 plus alpha T minus T node. T minus T node we have just calculated here. It is 20 by 3 into time. Value of alpha we know 10 raised to power minus 3. Value of R node we know that is 100. So value of RT, we can effectively write that RT will be 100 times 1 plus alpha, that is 10 raised to power minus 3, into 20 by 3t. So this will be the value of RT. Now using this value here, potential is 200 volts. So integral will be 0 to 30, as time is varying from 0 to 30 seconds. 200 square divided by 100 into 1 plus 20, 100, oh, sorry, not 100, 10 raised to power minus 3, 10 raised to power minus 3 into 20t by 3. So that will be the final value of integral. It will be solved like this. This will be 200 into 200 divided by 100, so 400 out of the limit 0 to 30 into 1 divided by 1 plus 2 into 10 raised to power minus 2 t by 3 into dt. Now again it can be solved as we can take this whole value common, so we can make it we can simply take its integral in the ln form. So its ln form will be equal to 400 as it is it is 1 plus nx type integral. So it will be, integral will be ln 1 plus 2 into 10 raised to power minus 2 by 3 into t divided by n, that is 2 into 10 raised to power minus 2 by 3 into limits, that is 30 and 0. This term will go here and we will have 1200 by 2 into 10 raised to power minus 2, and here we will have ln 1 plus 2 into 10 raised to power minus 2 by 3 into t limits 30 to 0. This will give us 600. This will give on the top, so we will get 60,000 or 6 into 10 raised to power 4. Now putting these limits, we will get ln into 1 plus 2 into 10 raised to power minus 2 into 3 multiply 30 minus ln 1 plus 0. When we put t is equal to 0, this whole term will reduce to 0. So this will be 10 and 6 into 10 raised to power 4 into ln, this will be 1 plus 0.2 and 6 into 10 raised to power 4 ln of 1.2, or we can say ln of 12 by 10, and ln of 12 by 10 is equal to 6 into 10 raised to power 4 ln of, that will be 6 by 5. Now comparing, here none of the options actually matches here, so none of the option are right because none of the option is matching. Moving to next one. So we have a diagram in a circuit shown. The resistance R is variable resistance. For R is equal to, if R is equal to, small r is sum F times capital R, heat generation in R is maximum, then the value of F is. So first we have to calculate value of heat generation, value of heat in through the small resistance, and then we will maximize that. So to find out the value of heat across this R, small r, what we can do, we can either find current through it or potential across it, and then using those values we can find out heat across it. So first, total resistance of the circuit, as this R and small r in parallel, so their combined resistance will be, we can say, R dash, and R dash will be small r into capital R divided by small r plus capital R. Now this R dash is in series with R, so total resistance RT of the circuit will be RR by R plus R, that will be equal to, taking LCM, RR plus R square divided by R plus R, and that can be written as R square plus 2RR, R plus R, further R we can take common, so 1 plus 2R by R plus R. Now current through the circuit, so I will be potential divided by total resistance. So suppose potential is E, so it will be E by RT. So it will be E times R plus R divided by R1 plus 2R. Now this is the current which is flowing through this circuit. Now, so this is the I. As at coming to this point, suppose this is point A. When current I comes to point A, or it reaches as point A, then it will split into the two parts. Some part will go through resistance capital R, and some part of this current will go through resistance small r. So we will find out value of current flowing through this small r, and as these both are in parallel, so current through small r will be given as total current, that is I, multiply by opposite resistance of small r, that is capital R, divided by their sum, so R plus R. So using this, value of I is this one, E R plus R divided by R 1 plus 2R multiply R divided R plus R. Now R plus R get cancelled and we will be left with ER into R1 plus 2R. So this is the value of current flowing through this resistance. Now we know the value of current, then we can find out heat. So heat will be I square into R, and for small r resistance, this formula will be heat through small r resistance is equal to current through small r resistance into its resistance, that is small r. So heat will become heat through small r resistance will be square of this term, so E square R square. Okay, we can also cancel this R, so R is not needed here. By 1 plus 2R square into small r resistance, that is R. Now to maximize this, what we have to do, we have first we will take derivative of this, and then finding the value of small r, and then we will compare that with capital R. So as we have to take derivative, so derivative with respect to small r, because small r is variable here, so E square will stay constant. Now we will be left with R by 1 plus 2R ka square. So first we will take 1 plus 2R square as constant and derivative of R. So it will be 1 plus 2R square plus, now R as constant and derivative of 1 plus 2R whole square derivative. So it will be minus 2 1 plus 2R minus power minus 3 into derivative of 1 plus 2R, that will be 0 plus 2. So it will be E square 1 plus 2R square minus 4R divided by 1 plus 2R power minus, it will come down, so it will be plus 3. Now we have to equate this term equal to 0, and actually again I think we made some slight mistake somewhere. Okay, yes, I found the mistake, and the mistake was that here while taking common it should be R. So it should be R, it should be R, it should be R, because if we equate this equal to 0, we will be only left with small r, and while finding value, we have to find it in some other terms, and some other term needs to be there. So that's why I found out that I have made a mistake. So this will be r, this will be r, this will be r, r, and r. Now we will equate this term to 0, and when we will equate to 0, this will reduce to 0, and both of these terms will become equal to each other. Only then they can be, their subtraction can be 0. So 1 plus r plus 2r square is equal to 4r r plus 2r cube. This square cancel the cube, and we are left with 4r is equal to r plus 2r, and from this 2r is equal to r, and r is equal to half of capital R. So from this, f is equal to half, and that we have to find out. So value of f is equal to half when power across small resistance small r is maximum. So with this, we end this video here. Hopefully what we have covered till now is helpful to you. Again, if you have any doubts or suggestions, you can put them in comment section. I will try to implement them. And if you find this video useful, do press the like button, share as much as possible, and subscribe to our channel. Also, if you want to donate us something, then you can scan these QR codes and donate us with whatever amount you want. Any amount will be helpful or appreciated. So again, thanks for watching, and we will meet in next video.